This video demonstrates the challenge of managing cooling system performance in a changing data center environment. It also illustrates the use of a digital twin to overcome this challenge. Cooling system performance is a balance between the competing objectives of thermal compliance and cooling system efficiency. This is a real data center from Binghamton University in New York that is part of a research consortium called ES2. Future Facilities belongs to this consortium and has access to this data center to perform studies. The data center has a modern design with containment, monitoring, and cooling system controls. Currently, the cooling requirements of all IT units are being met at a PUE of 1.7. In this example, a business unit wants to install an IT pod. The capacity requirements are within the space and power design limits. It would seem the pod could be installed without a problem. On this basis, the request was approved. However, after the installation, two IT units in the adjacent aisle lost cooling capacity and put IT reliability at risk. This outcome was missed because the detailed response of the cooling system, including airflow and cooling system operation, was overlooked. The inability to understand cooling system performance not only caused this problem, but also greatly limited the visibility of options to solve it. There was only one option the data center management team was certain would fix the problem, and this was to cool the whole room down until the alarm stopped. This approach eliminated the compliance problem, but at the cost of a higher PUE. That was the result of having to supply more air and reduce the supply air temperature. And this highlights the challenge. The inability to visualize airflow and cooling system operation makes it difficult to balance compliance and efficiency, which puts cooling system performance at risk. Let's return the cooling system to its original settings. This overheats the servers again. From this point, let's use Digital Twin to design a solution for this request. Digital Twin simulates the physical behaviors that determine cooling system performance after the IT pods have been added. The simulation for this data center runs on a laptop within an hour. Here we see the Digital Twin simulation predict the behavioral change that will cause the thermal compliance problem. Without simulation, the only known option to eliminate this problem was to provision more cooling. But with Digital Twin, the root cause is clear. This is a local airflow problem, not a room-level cooling problem. This problem can be solved without having to provision more cooling. This can be seen more clearly by isolating the cabinets that are interacting with each other. From here, Digital Twin simulation capability was used to design a solution. Any fix that can be imagined can be simulated. With the airflow problem in mind, two high-density racks were repositioned within the pod. After making this change, Digital Twin was resimulated. This solution looks promising. It solved the local airflow problem that was causing poor cooling performance. And this can be seen clearly by comparing before and after. This configuration meets thermal compliance and decreases PUE by 7% by reducing the airflow supply from the facility and avoiding having to decrease the supply air temperature.